Right, and back with the next to the last video on the transformations of sine and cosine graph. And this video is related to your worksheet that's entitled Phase Shift Changes. So phase shift changes means that there's horizontal transformation taking place. And how do you know that's going to take place? It means that you have something in parentheses. On your worksheet, they always use theta minus an angle to show the phase shift. But I always like to use X. I'm just used to that. You don't have to. But I'm just writing both of these because they mean the same thing. So if you look here, the coefficient of this is 1. So the amplitude is 1. High point is 1. Low point is -1. The phase shift, so PS stands for phase shift, means that you're moving pi to the right. So you're moving the opposite direction of the sine, you're moving pi to the right. So compared to the parent graph of sine of theta, every point is going to move pi to the right. Now I show that algebraically here, and this because I've limited space here on this worksheet and the next one, you only have to graph one period. This is how I like to do it algebraically. Some of you can figure it out mentally, but let me show you this. NSP stands for new start point, and EP stands for new end point. So to set it up algebraically, I compare it to the parent graph of sine. So notice the starting point for y equals sine of x is 0. So I take what's in parentheses and set it equal to 0. I add pi, and so my new start point is pi. And you can see algebraically, if this didn't make sense to you when I explained this, that it translates to this, you can see here, you're moving pi to the right. So I'm going from 0 from the parent graph, and my new starting point is pi. And then the sine graph, as you move to the right, the first end point is 2 pi. So to find my new end point, I take what's in parentheses and set it equal to 2 pi and solve for x. So now I have my new start point and my new end point. Okay. So in between, just like in all the other videos, in between the start point and end point, there are 3 angles. So what you do is you just take the midpoint. So as I box these in, the midpoint between these here, all you do is you add these together and multiply by 1/2, and you get 2 pi. That's the midpoint between these two. And then what you do here is you add these two and multiply by 1/2, and there's your angle that's the midpoint between these. And you do the same here, you add these up, multiply by 1/2, and then there's your midpoint between these two. Okay, so I've written those new angles down here. And nothing changes in the shape of the sine graph. So at my new start point, I'm on the horizontal. And then as I move to the right, to the first angle, I'm at my high point. And I have to go through the horizontal to the low point and then back to the horizontal. So this time I'm only having you graph one period. So the length of that one period is 2 pi. The domain, it wouldn't be negative infinity to positive infinity. Your domain would be pi to positive infinity, because you're starting here and see there's an arrow this way. And then if you look on your worksheet, so you have domain range. Range is 1 to -1. And then the period I talked about is pi to positive infinity. Phase shift, I wrote up here, is pi to the right. And then there is no vertical slide. Okay. So again, I did one with sine, and then I want to do one with cosine. So this one's a little more involved. So again, here is your equation here. You can see that there is a phase shift because inside the parentheses you have plus pi over 2. And again, they use theta on your worksheet. I'm going to use x. These two mean the same thing. Again, your amplitude is 1, and your phase shift is going to be pi over 2 to the left this time. I'm going to use the same strategy as in the previous problem. New start point, new end point, set equal to 0. So you end up with negative pi over 2. So you have a negative angle. So that proves algebraically why it's the phase shift pi over 2 to the left. Okay? And then we end up at 3 pi over 2 here for your new endpoint. Now what I did, this is a little more involved because you have two fractions here. So to find the midpoint between these two, you add these two up and you multiply by 1/2 and you'll get pi over 2. I don't have room to show the other two, but just watch this. This is pretty easy. You can do it mentally. To find your midpoint between these two, add those up. That goes to 0. So then your midpoint is 0. And right here, these two right here, add these two up. So that means you would have, what, 4 pi over 2, which is 2 pi, multiplied by 1/2, and that's pi. And then as you graph here, you have negative pi over 2, 0 pi over 2, pi, and 3 pi over 2. At your starting point, you're at the highest point here. And then you go from your high point as you move to the right, you go to the horizontal, low point, back up to the horizontal, and then you're back at the high point. Okay. Because I have arrows in both directions here, you can say the domain here is from negative infinity to positive infinity. Your range is 1 to -1. You have your phase shift of pi over 2 to the left. The length of your period, this is still 2 pi. And then there's no vertical slide. Okay, so I want to go back and I want to make a correction. I just realized here, just to be consistent. So over here, I didn't do it, so that's why I didn't say this, but actually this is continuous, so I'll put an arrow here. So actually your domain would be negative infinity to positive infinity, because this is continuous. So I wanted to make that correction here. Okay. All right. So again, email me if you have any further questions. Look back at the other videos that I've done if you're confused about anything. And there's just one more video, and that has to do with period changes. So the length of the period, and all the ones that we've done so far, is always 2 pi. The period can stretch, so become greater, or it could shrink, it could become smaller, and I'll show you how to figure that out. Right, stay safe and healthy, and I hope you're doing well.